E. coli infections and then extraintestinal E. coli infections. We're talking about some of the virulence factors associated with those and how they confer the ability to have those associated pathologies. But if we're talking about just a stripped down factory model E. coli without those virulence genes, without the plasmids, without the translocomons, prophages, what are some of the basic virulence factors associated with E. coli? Capsules, some encapsulated strains. And think about the pathogenesis, what these E. coli bacteria have to do in order to establish infection. Yeah, Fimbria, Fimbria, and they use that for what? Yeah, you got to be able to attach, exactly. So that's a major one. And then a feature of E. coli, these are gram-negative rods, right? So think about their shape. Anything else about their character? Yeah. What does this mean? Flagella, yes, I love when people pantomime. That's exactly right. They have flagella, 5 to 10, and that is used for motility. Yeah, to help them get around. All right. So in those intestinal infections, we talked about 5 different pathotypes. So same species, but pathotypes are sorted by their ability to cause similar pathologies. We sorted those further into non-invasive ones and invasive ones, 3 and 2. Do you guys remember the 3 pathotypes associated with non-invasive intestinal infections? Super. Yes. So we've got EPEC. What's one thing that comes to mind about EPEC, and what does EPEC stand for? Or acronyms? Enteropathogenic E. coli, Escherichia coli. Well, the P was helpful as alliterative, so there were some other words that can kind of come to mind to help you think of the pathology associated with EPEC. What other words should pop into your mind when you think EPEC? Pediatrics. What else?
Platforms.
Platforms. Let's hang on that one for a second. What about those platforms? What's that, and how does it contribute to the pathology? Staph is associated with which pathotype?
I did this. The cytoskeleton is rearranged so it's flat.
Beautiful, yes. So he said that what happened, good job. With EPEC, what happens is you have BYOR, bring your own receptor, as is translocated into an receptor. It implants that on this target intestinal epithelial cell, causes cytoskeletal rearrangements to go on, just like John said, and that causes almost like a reaction in the cell. So the cytoskeleton will raise up and cause these platforms or pedestals to form. And that destroys the functionality of those enterocytes. So you get those diarrheal symptoms. ETEC, that's another one of the non-invasive ones. It stands for what? What does it mean? Toxigenic E. coli. So pretty good guess it's going to have some toxins. What are those 2 primary toxins we talked about that are associated with ETEC? Yeah, heat stable, and the heat labile one. So LT for labile and ST for stable. Exactly. And those 2, when those bacteria secrete them into target cells, will cause dysfunction in those enterocytes, and then you get diarrheal symptoms. So it's usually watery diarrhea, but we're still not talking about dysentery or bloody diarrhea. We're just dysregulating the function of those enterocytes. One more non-invasive pathotype, and it was already mentioned. Yeah, EAC, and the A stands for aggregative. So stacked brick morphology, where you have all those E. coli bacilli stacking on top of each other, and that will cause a shortening or disruption of the microvilli, which compromises their ability to function, to do absorption. So you get diarrheal symptoms because of that. The 2 invasive pathotypes are STEC, yeah, and EHEC, so we're kind of classifying that as one type. And then the other one? Which one? Enteroinvasive, yeah. Enteroinvasive, yeah. So with enteroinvasive, you actually have invasion of those enterocytes, right? So the bacteria can get in. They behave very much like another genus that we're going to talk about shortly here today. You guys remember what that other genus was? Shigella, yeah. So kind of think of those two very similarly. EIC, that invasive E. coli, and Shigella, they behave very similarly. They're able to move in, not only invade those intestinal epithelial cells, but invade laterally. So they don't spend much time outside and they're protected from immune defenses that way. Because of that, they will destroy and cause destruction of the epithelial cells in the intestines, and you get symptoms that could be like bloody diarrhea. So more severe bloody diarrhea is possible. And then you mentioned STEC and EHEC. What do those stand for?
That's all I got.
Okay, no, that's fine. I respect that. STEC, anybody know what ST stands for? Shiga toxin producing, yes. And EHEC, what's the H? Hemorrhagic, exactly. So again, these are invasive. They have kind of combined symptoms where you have destruction of the microvilli, so some contributions towards diarrhea that way, but also producing some toxins, and those toxins are Shiga toxins, STX1 and STX2. Those are the genes that encode Shiga toxins. So those toxins will also cause destruction of those epithelial cells. And because of that destruction, you get dysentery, bloody diarrhea. Extraintestinal infections. You guys throw out a couple of types of extraintestinal E. coli infections. The big one is UPEC, right? One of the big ones. And what is UPEC? Uropathogenic E. coli, exactly, yeah. So these are enteric bacteria that somehow get into the urinary tract and cause infection there, they cause UTIs. And are they major cause of UTIs or minor? Major. Over 75% caused by E. coli. Okay. What else besides urinary tract infections? UTIs. Meningitis. What's the acronym for the meningitis that's of concern in the age group? NMEC. And we're talking about what age group? Neonatal. So NMEC is neonatal meningitis E. coli strains, like K1 strain in particular. Anything else for extraintestinal E. coli infections? That's just the kind of like overarching acronym for extraintestinal. Yeah, that's a type of infection. So these are hospital-acquired infections that can occur. But like, what kind of systems can be affected? Or other pathologies. If you get stool that somehow contaminates an open wound, would that be problematic? Absolutely. You get some very purulent infections there. So that's the point. It's really important to clean that area, keep it bandaged, keep it covered, so you don't get wound infections caused by E. coli. Also, pneumonia, sepsis, things like that are possible as well. All right, well that was a fun review. All right, we'll move on, and then I'll pick up and do another review tomorrow just to recapture some of this stuff. So we're starting off with some of these other enteric bacteria today. First with Salmonella. You've probably heard of Salmonella before. Generically, they cause salmonellosis. We briefly talked about Salmonella in Block 1 when we were talking about nomenclature and how things are categorized. This is an example of some crazy taxonomy where we have some meaningless species names and practically meaningless subspecies names. So when we're talking about some of these organisms, we really get down to the serovar level before we get to anything meaningful. Serovar is a serological variant. Okay, so when you have the genus Salmonella, which belongs to under the family, what? Anybody remember what family? That massive family that Salmonella belongs to? Same as E. coli, same as Shigella. Big long name starts with E. Enterobacteriaceae. So we're in that big family. Now we're down to genus Salmonella. we technically have two species, Bangori and Enterica, but like 99% of these species fall under Enterica, so we have hardly any relevance in even talking about Bangori. At the subspecies level, we have 6 subspecies. But even at that level, the vast majority of clinical isolates are coming from subspecies Enterica. So we've got Salmonella, Enterica, subspecies Enterica. And now we have 2,500 different serotypes, many different clinical serotypes. We have run out of names to call these things. These are some of the major ones you hear about: typhi and paratyphi, they're very serious. Typhimurium enteritidis, also very common serovars. But they have named them after celebrities. There was one up in Chicago in Cook County that was named after Michael Jordan in the 90s because the infectious disease doc was a basketball fan. So that was like M. Jordan-I. I mean, but a lot of people get bacteria named after them who have nothing to do with diarrheal illness or anything else. So yeah, they've really, 2,500 serotypes, all of them named. They've like scraped the bottom of the barrel on some of those names. But point is, like, there is a specific proper nomenclature. It's very long, very cumbersome, and it usually can get shortened to just the genus and then that serovar. But a little differently than what we've done in the past, when you want to, the right convention for that serovar is capitalized and non-italicized. It's one of the few instances where we would not italicize, we would capitalize. So Salmonella typhi is generally understood to be that serovar under Enterica, subspecies Enterica. Okay, so when we're talking about diseases caused by Salmonella, we'll talk about the big bad one first, and that's typhoid fever. We do not see a lot of cases of typhoid fever in the US. So this is one of those things, increasingly we'll be talking about geographical differences and why it's important to study and do surveillance on where these things are most prevalent. In this world map here, these are sort of the hot spots of where you might get typhoid fever, which if you think of nothing else when you think of typhoid fever, you think about the fever. It's a very febrile disease, much more serious generally than the gastroenteritis that is usually associated with Salmonella infections. In terms of military relevance, a couple of my assignments, I may have mentioned, I spent 2 years down here in Kenya doing, among other things, diarrheal surveillance. We did a bunch of things. So we were working with the Americans there, we were working with the British soldiers, we were working with the Kenyan soldiers, and trying to figure out what was making those guys sick. So collecting their stool specimens, taking it, yeah, it was fun. Taking it back to our lab and doing like a full exhaustive workup to see what the distribution of these enteric diseases were. So, especially for you guys, 18 deltas in this room? A couple of you guys? Okay, so I don't know if 18 deltas are a group that we like to work with because the ODA teams oftentimes get sick en masse with diarrheal disease, common exposures, right? So 18 out of 18 guys go down, right, with diarrheal disease. And this is a problem of military relevance. We can't afford to have that. They're out of commission for a couple of days. So the military spends a ton of money and effort doing surveillance efforts, so we know what you guys are likely to encounter when you go to different parts of the world. And again, even if you are not going to different parts of the world, your patients will be. So you need to have a good understanding of these exotic, tropical diseases or wherever. So yeah, that was typhoid fever. It wasn't uncommon, but we definitely saw cases in Kenya when we were doing surveillance there.
Were you at Bay?
No, I was out in Kericho, which is so here's Lake Victoria, right? I was about 2 hours east of Lake Victoria and about 4 hours west of Nairobi. And that was where I stayed for that entire 2 years, but I did some surveillance out on the coast, Lamu, Monte Bay, and some up north in Turkana as well. Were you?
I was across the border in Somalia.
Okay.
Yeah, we go back to
Okay, yeah, that is nice fish. So, yeah, and then also I spent 2 years here, if you can see that, in the Republic of Georgia. That was my last assignment. And there too, we saw, that has a fairly good incidence of typhoid fever as well, not quite as high as Kenya, but do surveillance all up and down the eastern flank of Europe in that assignment. and just try and characterize what's circulating again. So talk about that a lot. But there are hotspots. Africa, a lot of hotspots. The Indian subcontinent, India, Pakistan, Bangladesh, Southeast Asia, Indonesia, Malaysia, a lot of those places. Some spots in South America. Okay, so in those areas, particularly in the underdeveloped or developing parts of the world, it is extremely difficult to have lab support. Or maybe it's war-torn like Ukraine where their lab capabilities are decimated right now. They can't do standard basic workups. So in those areas, in these hotspots where you know you have typhoid fever, empiric diagnosis is very common. Those docs get very good at recognizing signs and symptoms of typhoid fever and how that would be distinctive from other diarrheal disease presentations. All right. With typhoid fever, let's see if the pathology is on this slide, but talk about symptoms first. There are non-specific symptoms initially, and that's very common. So just general indications that something is going wrong. Diarrhea or constipation, so that would be a very confusing differential to consider. There are a lot of things that can present like this. But sometime during the second week of infection, when somebody's contracted typhoid fever, which is usually fecal oral route contaminated with water contraction, they might be able to get some more specific symptoms. The most classic one are these rose spots on the trunk. You can see this in a light-colored patient where, you know, these sometimes faint spots are pretty visible here, but you can imagine if you have a darker skinned patient, it becomes very difficult to see this, and it's also on the trunk as well. It's a little bit raised, it's a macropapular rash, so you might be able to feel it, but it's not like that sandpaper rash that we talked about. It was associated with what bacteria?
Well, not rheumatic.
Not rheumatic, but, and yes, strep, but what species? Pyogenes, yeah, group-based strep, yeah, scarlet fever, sandpaper rash. This is a different rash, so you don't get that textural hint. Okay, so 30% of patients have this rose spots, and that is, if I can skip over to, well, let me just hit these complications. If it gets really bad, you can have potentially fatal outcomes when you have significant damage to the intestinal barrier, sepsis, etc. But treatment is extremely important, fast, rapid treatment so it doesn't progress. All right, so going on to this pathology a little bit, you get these enteric bacteria, you ingest them, they survive, they're a little bit acid stable, so they survive the trip down through the stomach. They get into the intestines, and then remember when we were talking about the GALT, the gastric or GI-associated lymphoid tissue, the architecture there? Remember when we were talking about the M cells, the microfold cells, and their function? So that's kind of, their function is to translocate antigens that are picked up in the lumen of the gut and present them down to all the immune cells that are waiting in the lymphoid tissue down here, right? So this ends up being exploited, and it ends up being the Achilles heel for Salmonella. Salmonella will invade those M cells. They'll make it to the other side, they'll survive to the other side, and they'll get all the way into the mesenteric lymph nodes that we talked about. It's on the other side. There, they will get picked up by macrophages, which are supposed to be destroying them, but through years, millennia of evolution, they survive or evolved survival mechanisms to survive macrophages. And those macrophages will carry them in the bloodstream to different organs. So they'll be disseminated to organs like the liver, or the bone marrow, or the gallbladder. And this is where you get much more serious disseminated disease in those cases. Even in these serious diseases where you have dissemination of Salmonella, the mortality rates are still, as we saw on the last slide, not super high. So your immune system should be able to get the upper hand eventually, and you should be able to clear those Salmonella bacteria. However, a small percentage, 2 to 5% of those typhoid patients are not able to clear those bacteria. And they can go on to become carriers. There's a time period associated with when you are considered to be on carrier status for Salmonella, for typhoid fever specifically. And that's when you were shedding this bacteria in your stool for over a year, and you're on carrier status. Normal infections, even after your immune system has more or less gotten control of this infection, you'll still shed it in stool for a couple weeks. It's not something that goes away immediately, but you shouldn't be shedding those bacteria for much longer. So what happens with these carriers is these bacteria are able to take up safe haven. They evade interference from the immune system, and they will lodge in the biliary tract and gallbladder, which you guys are studying in A&P right now, right? Sort of, yeah, digestive. Okay, so yeah, there's a picture here where you can see the gallbladder, which is primarily where they will hide for that time period. Right below the liver, a small little organ there. And there are risk factors associated with which types of patients will go on to become carriers of typhoid. Women with history of gallstones, those are like the main, and older people as well. But you can contract typhoid fever as a kid and become a carrier as well. That's very possible. What we think probably happens is for people who have gallstones, cholelithiasis, these stones in your gallbladder, it seeds the bacteria so they can form biofilms on those gallstones and just kind of stay unperturbed in that area for years and years and years, potentially the lifetime of that patient. So that's sort of how we think that happens. In terms of very famous carriers, typhoid fever, anybody heard of typhoid Mary? Yeah, most people have. What do you know about typhoid Mary?
Asymptomatic carrier who infected like 50 people.
Mm-hmm.
She moved from job to house to house because she kept escaping.
Yeah, really interesting case. But like you said, this was around the turn of the century, late 1800s, early 1900s. She'd cook in New York, I forget which borough. But she was a carrier. She wasn't in great health, but she was asymptomatic for typhoid fever. So she was shedding this bacteria in her stool, and she probably contracted that infection earlier in her life and had been shedding large amounts of bacteria. What do we know about hygiene around the turn of the century? It was phenomenal. Yeah, so people didn't wash their hands. They were like, God knows what kind of like bathroom hygiene they had, but not great. So cooks who were carriers of salmonella very commonly were shedding that bacteria into the food when they were preparing food for families. And that's what she was. She loved cooking. They paid a decent wage. She was good at it. So she moved from, she was infecting whole families. There were fatalities that were pretty well linked to her. 3 confirmed kills. And then she would pick up, move to a different part of town, change her name. I mean, we don't have good systems of tracking people down back then, so she was pretty successful at being able to do this for years and years until they finally apprehended her. I mean, the epidemiologists at the time must have had their work cut out for them. It must have been very difficult. But yeah, they knew she was a carrier. They asked her nicely, can we remove your gallbladder, because that's what was done back then. And they still do it, I think, sometimes. She was like, hell no, you're not doing that. So they ended up incarcerating her, basically, forcibly. And then they released her on condition that she would never, ever go work in the food industry again. She was like, okay, deal. So she gets out, and she goes straight back to cooking for people. Sickens a bunch of more people, kills more people, and then after a while they were finally like, okay, we are taking you in forever. Threw away the key, and she died in custody at the age of 69 from pneumonia. Everybody dies of infectious disease back then, right? But yeah, that was, and they never took out her gallbladder, but they did autopsy her, and when they looked at her gallbladder, guess what they grew? Tons of salmonella. Okay, so. And these days, antibiotics can clear that up perfectly. Easy to diagnose with culture, just throw it up on culture. So that's typhoid fever. If I didn't hit this point, Salmonella typhi is the predominant serovar, but paratyphi is another serovar, usually associated with a milder form of disease. All right. typhoid fever, been that, now we're talking about gastroenteritis, so non-typhoidal fever, Salmonella serovars. Two main ones are enteritis and typhimurium, but remember, there's 2,498 other ones out there, so a ton of them. Much like regular, when we're talking about typhoid fever, transmission is very similar. You get it through fecal-oral route, contaminated food and water, but particularly with these food-producing animals that carry salmonella, those are major, major sources of gastroenteritis. And this is pretty common. Also, contaminated surfaces, how might that present a risk, do you think?
Food preparation.
Yeah, like if you're working with chicken, like raw chicken again, the big culprit, and you're working with it on a cutting board, even if your hygiene is perfect from that point on, you cook it thoroughly, 165 degrees, heat destroying temperatures. If you go and cut up vegetables on that same cutting board, the bacteria can be transmitted to those vegetables. Okay, so I think some people don't, they're not aware that those risks occur. So cross-contamination, contaminated surfaces is a big source as well. And then directly from our pets, particularly reptiles, the CDC has actually put out a public health advisory specifically for, a lot of reptiles carry it, reptiles, but for turtles, little turtles, like those little guys that are 10 centimeters, are the biggest carriers of salmonella. A lot of cases linked back to little turtle pets. People and their weird behaviors with their pets, like kissing them, things like that. I remember going back to chickens, just real quick, a little anecdote. I remember when I was a kid, my mom, she was not what you would call a domestic goddess, but she would send us out, my brother and I, she'd send us out the door for school in the morning. This like really rapid breakfast. She'd put Ovaltine in a glass, dump in a little bit of milk, and then she'd crack a couple raw eggs in there and give it to us because that's what she had when she was a kid. And it would fill you up. I mean, almost nauseate you. But I remember I asked her, like, I think this is bad for you. I think this is not a great idea. And she was like, it's fine. I had this every single day. But I was right. It is a bad idea to ingest raw eggs because they oftentimes do have salmonella on them. I'm surprised I didn't get gastroenteritis a lot when I was a kid, but that is a big no-no when you're cooking or just eating stuff in general with eggs. Cookie dough, all of that. Oh, tell me I didn't just stand up. You guys know you shouldn't eat raw cookie dough.
No, you do.
You don't have to put an egg in it.
Okay, let it be said for the record, don't eat raw cookie dough. Unless it's one of those brands that they specifically marketed because people love raw cookie dough so much, where it's been, like the eggs have been, whatever, irradiated or whatever.
Those aren't as good.
They're not as good, I agree.
You gotta risk it.
Yeah, well, do your own risk analysis. I'm just saying, you shouldn't eat raw cookie dough. Okay, in terms of like your average normal gastroenteritis infection, pretty normal stuff. The diarrhea can sometimes be bloody, it usually isn't with normal gastroenteritis. Wouldn't be, like non-typhoidal salmonella wouldn't be the first thing I would think of if a patient had dysentery, but it is possible. Onset is anywhere between 12 to 3 days after ingestion, usually. It should be self-resolving, and that links down to treatment as well. So if it's self-resolving, generally antibiotics, if you can afford not to administer them, that would be great, because it will take care of itself quickly. Most gastroenteritis cases do, so it's always nice to avoid antibiotics whenever possible. But that said, this person, if they have severe diarrhea, they're going to be losing fluids. So one of the most important countermeasures is making sure they stay hydrated and trying to offset the risk of dehydration and all the problems that accompany dehydration, including kidney failure, which of course is very serious. There are some at-risk groups who can get invasive disease, septicemia with some of these serovars, even typhi and paratyphia. Cholera suis is another NTS serovar that's associated with septicemia. These complications, the bacteremia, the osteomyelitis, and the meningitis would be associated with people who have problems with their immune system and who aren't able to clear the infections. So the bacteria would be disseminated to off sites like that, like bone and up into the brain. But not a significant bacterial or etiology behind meningitis. It's just linked to it, but not a significant source. In terms of lab diagnosis, we have a bunch of selective and differential media. Some of it specifically for Salmonella shigella. It's called Salmonella shigella agar. We have other ones as well. But this is common enough where we have these routine media types in lab that we use. So it's just part of our standard workup. If somebody is suspected of having typhoid fever or enteric fever, we can look at blood specimens. We can see if they actually have bacteria in their blood, disseminated infections. But more often, we'll just take stool from the person and see if we can culture out Salmonella from the stool specimen. It is possible to shed the bacteria in urine as well, but that would probably not be the preferred specimen type. And if it's negative, that would not be a good rule out for an infection with Salmonella. Once we grow up Salmonella and idea Salmonella, we can do further typing analysis using anti-sera against those antigens that we talked about. Real quick, you guys remember those 3 antigens for Enterobacteriaceae that are widely useful for typing purposes? O, the somatic polysaccharide. H, what was H antigen? Flagella. And then K, and that was capsule. Yep. So we can do some typing, particularly with the O and H antigen. Resistance is an issue, so when you grow up those cultures, you can pick those colonies and do set up ASTs. And then PCR is possible, but not routinely used for diagnostics. We see blended culture with a bunch of these bacteria, gram-negative rods staining in this specimen, Salmonella typhi. Right. Any questions about Salmonella? Yes, sir.
I've got one. It's a dilemma I've had most of my life. So, when you're cooking chicken, right?
Yeah.
And you put raw chicken in the pan and you use those tongs and you turn it.
Yeah.
Are you supposed to get another pair of tongs? So are you using 2 pairs of tongs every time you're making chicken? What do you do?
That's
and
a
what's
great,
better?
that's a great question. So I cook chicken all the time, and I did some chicken last night. I was thinking about Salmonella.
You too.
Yeah, good. That's great. So I use the same tongs because I'm lazy, and I don't even know if it's really good standard. What? No, here's my rationale. Hear me out. So I'm like using the tongs. The surface is like whatever that whatever that surface of tongs is, but it's not conducive to transfer in the first place, particularly. But you're handling cooking meat while it's cooking. So yes, I'm not like pressing the stupid tongs against the bottom of the pan to sear off any bacteria. Wouldn't work anyway because of the surface. But no, like once that chicken is done and I'm satisfied it's over 165 degrees, I use the same damn tongs and I just give it to a plate. I know, it's risky.
You live on the edge.
I do. I know. That's you have. There are criteria that a patient has to meet in terms of severity where antibiotics would probably be considered, but they have to meet those criteria, and those are things like you'll learn in GI and other courses. But yeah, it's linked to presentation entirely, whether or
I
not
think she
they.
said anti-diarrhea.
Oh, I'm sorry. Okay, so like the anti-motilities, loperamide, stuff like that. Oh, and is that situation dependent though? I mean,
They usually don't treat diarrhea for at minimum 72 hours. They should provide to get rid of something.
Yeah.
They don't get any blood whatsoever. They normally start doing testing. They don't let that go to your body's way getting rid of the pathogen.
yeah.
Some people are quick to administer like antidiarrheal medication, and then after they should let it.
Irritation in these
Yeah, and I think that's true of a lot of like over-the-counter treatments that people want supportive care, they want symptom relief really fast, but some of those symptoms we've already talked about. Symptoms are there to naturally clear that infection. But I remember there was a big study called the Treat TB study, treat is a big acronym for like treating blah 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 TD, traveler's diarrhea, in some of these hyper-endemic areas. And they were evaluating anti-motility regimens and whether or not the juice is worth the squeeze when you have mission essential work to do. Like, you can't have a bunch of tankers in a tank with explosive diarrhea. You can't. I mean, you can. You can't have a bunch of pilots flying planes when they're like have several episodes of diarrhea per hour, right? It's not good. So maybe in those situations, I don't know, like prescribe your anti-motilities and then
In the military, they only do it for a mission.
Okay.
Like if you're on the mission, you have to go, let me do anti-motility stuff, but after that, unfortunately.
yeah, okay. So that seems sage and consistent. All right. Moving on to Shigella. Well, I think we'll close out Shigella and then go on a break. So we've got an organism that is similar to E. coli in a lot of ways, especially that one haplotype when we're talking about intestinal infections, EAIC. So again, kind of think about those together. Unfortunately, there is a need to know these different species, major species of Shigella, which are grouped according to severity. So at the very top, Shigella dysenteriae, also known as Group A. This is the most serious species of Shigella. So it's the one associated with dysentery. It causes outbreaks, and this is really the one to know. However, in terms of endemicity, and you guys know what I mean when I say endemicity? Okay, it means like remember that map when we were talking about typhoid fever and those hot spots? Endemicity means where those diseases are likely to be found. An area that is endemic for typhoid fever is a hot spot for that disease. An area that's endemic for dengue, an area that's endemic for leptospirosis or something else. So with dysentery, it's not endemic in a place like the US, and that is linked in part because of really good hygiene standards here. We do not come across a lot of cases unless they're travel-associated cases of dysentery. What we see is down here, Soni, 85% of our cases are attributed to this species. It is the least virulent of those four, thankfully, and you usually do not see dysentery or bloody diarrhea associated with Soni. It's usually up there with dysentery. In the developing world, flexuria is important to know. This is far more prevalent than even dysentery. So this is the most serious and this is the most prevalent in the developing world. A little clarification there. For transmission, same, fecal oral contamination, 5 F's that we've talked about, undersized food, feces. High risk settings are important to kind of keep in mind. Places where you have overcrowding, when you have poor hygiene. This is also important when we're talking about the ID50. The fact that this has an extremely low ID50. It's one of those human-adapted species, so it doesn't have to do any adaptation to human hosts in order to be infectious. Because of that, only 1 to 200 bacilli are needed in order to establish an infection. When you have such a low ID50, you can start getting person-to-person transmission. So read, if you have explosive diarrhea, it's not pleasant to think about, but the person in your overcrowded situation next to you might also get that in fairly direct ways. And that also is responsible for cases that kind of pop up in the same household. If one person gets Shigella or shigellosis, it's likely that the whole household is going to be at risk as well. We did have an outbreak of shigellosis with the IDF back in 2023, pretty sizable outbreak, because people were very nicely sending care packages to those soldiers, and probably since the 80s we're sending soups and stuff, but the bacteria were growing up in those food items, and the soldiers were ingesting them, it's causing outbreaks of shigellosis. In terms of the pathogenesis, here too, like what we saw with Salmonella, we have that Achilles heel being the M cells in the intestinal epithelial barrier. But this is where we part ways with Salmonella. So with Shigella, you have that you have direct invasion of these epithelial cells, particularly at the M cells. And then you have that ability to move laterally from cell to cell and replicate in those cells as well. In the process, there's a lot of tissue destruction that's going on. So when you have shigellosis caused by Shigella dysenteriae in particular, it has some extra virulence factors associated with it. That destruction is so severe that you actually do get blood released into stool. That's the pathology there. What you don't get as much, unlike some salmonella, where eventually those macrophages will take up the bacteria in the mesenteric lymph nodes and disseminate it into the bloodstream, you don't really see that with Shigella. So it stays localized and mostly in the colon. So colonic epithelial cells are more susceptible to this disease. It does elicit a strong inflammatory response, which means in that affected colon mucosa, some of that will start sloughing off and it'll go into the patient's stool specimen. And you can see that it looks like amorphous, translucent in the stool specimen. But that's an indication that you have an inflammatory diarrheal infection going on. Some exotoxins that are associated with these virulent Shigella species. We've got some neurotoxins that can contribute to CNS issues, pathologies. Enterotoxins that contribute to the diarrhea itself, like the fluid imbalance, fluid accumulation. And then you also have the shigatoxins. So just like EAIC produced shigatoxins, just like STEC produced shigatoxins, Shigella produces these shigatoxins too. And they have the same target. They target protein synthesis in those intestinal epithelial cells. And if they diffuse out of the intestine, part of the pathology also contributes to pus as well, just like what we saw with STEC and EHEC. So this would be targeting the kidneys. You guys remember what pus stands for? Hemolytic uremic syndrome. So two things that are associated with pus. We've got Shigella and we've got STEC, and EHEC, particularly that O157H7 strain of E. coli. Symptom onset, usually within 12 to 48 hours. Cramps, fever, diarrhea, bloody diarrhea. Tenesmus, if you haven't heard that term before, it just means straining while you're trying to defecate. Severe cases, you will see some of that blood and pus and mucus shed off into the stool. There's a very descriptive, colorful term that's used to describe those stools, currant jelly. Currant is sort of like a grape, so the currant jelly is like a dark red, almost black jam look in those stools that's caused by the bleeding in the colon, so the lower GI tract bleed, currant jelly stools. Good indication that you've got a severe disease process going on. You can resolve this within 1 to 3 days typically, but treatment is important with Shigella usually, especially if you have more severe symptom presentation. And you also want to be aware that there are some common sequelae that can happen after Shigella infections. Reactive arthritis is one of those where you would have like that joint involvement, pain and stiffness in the joints. Sepsis occasionally, and then again pus, but pus is not associated with most of the species, just dysentery. In terms of lab diagnosis, we've got our selective and differential media, the Salmonella, Shigella augurs, and some other augurs as well to distinguish these colonies. Microscopy can be useful, but really if the patient is presenting with bloody diarrhea or inflammatory diarrhea like that, what we're looking for with microscopy, even more than the bacteria, if you're lucky enough to see them amongst all the bacteria in the stool specimen, are things like the red blood cells, things like the white blood cells that shouldn't be there in normal stool. Again, so like in this patient's stool specimen, this shigellosis, you see a bunch of red blood cells, you see some granulated nuclei, characteristic of neutrophils and other immune cells, and you might see some of that mucus and pus as well in the specimens. If you want to do a more rigorous workup, PCR is useful. Do PCR for the STX1 gene or the STX2 gene. It tells you if you have shigatoxins in there. Other virulence genes too might be targeted. So, okay, I've got 8:47. Let's take a 10-minute break and we'll pick up on Yersinia species.
Good to see you. Yeah, no worries. Oh, hell yeah. So I think what it is, you got one, still long. That's probably.
So you see what you got offside? Yeah. You got new songs and you got.
You gotta risk it, man.
I got a dishwasher, guys. Sorry, I got a luxurious one. I got a dishwasher. That works. That works. Might be the one that.
I know, that's, I just, I put,
No, for sure. Like, I'm putting the chicken in a fryer or wherever. I will pan, put it in on the skillet, whatever. Then you gotta flip it. You don't flip. You don't grab that hot ass chicken on the skillet. I don't either. She's like, I'm tired of doing all these dishes.
you just said you had a dishwasher.
STX1 has 15.
Raw eggs are good enough for raw meat. I agree.
Yeah.
I know.
You know what I mean? Like, is there like sort of safety and leading first in your life?
Start your shirt.
or it's just because that's how it's about. It doesn't mean that's how. Like as far as you kind of trick yourself on like I'll move over here. That's all.
The fun.
Honestly, I don't remember more about it.
Found it. You can't find it? You still looking?
I don't know. Last time I commented on something on Facebook, I just saw it this morning. I was like,
Yeah. You don't remember who it was?
if I see her name, I'll do it.
What if he says my wife is in every weekend and I can't go to his marriage, so I gotta get
So one that I guess,
He doesn't care to leave all
that's we've got a couple more pathogens to go through. Moving on to another genus now. Moving on to Yersinia species. These two species are associated with intestinal infections, but the most famous member we will talk about in a couple days, early next week, Yersinia pestis, right? Completely different. These guys more associated with gastrointestinal infections. Whenever I'm looking at organism names, I look really hard at the name itself and try to extract as much meaning as I can. See if it usually gives you a good hint as to what's going on. With Enterocolitica, it's not that helpful. It just tells you it's in the colon. But the remarkable feature here is that it mimics an appendicitis in its symptomology and its presentation, particularly in older kids and adults. With pseudotuberculosis, tuberculosis is famous and known for its ability to disseminate and spread outside of the lungs. So I would imagine that this is a reference for its spreading ability, that it is also able to spread and disseminate outside of that intestinal environment, that localized intestinal environment. So we'll see. With pseudotuberculosis, you get a lymphadenitis, which is an infection or inflammation of those mesenteric lymph nodes. Common transmission sources, these organisms are both found in the GI tracts of food-producing animals. So we find a lot of cases associated with undercooked pork, unpasteurized milk, and contaminated water. So the contaminated water is mostly when you have runoff from those animals that gets into the water supply. You're not able to have adequate hygiene to catch that. Because of this unique feature that they are cold-tolerant organisms and they actually grow better at 25 degrees Celsius and 37 degrees Celsius, they have a unique geographical distribution. Most of these bacteria that we're talking about, if they do have any geographical distribution at all, usually it's around equatorial regions in the warmer climates. But the cold tolerance of these guys makes most cases actually occur or linked to colder climates. So Europe, US, Canada, Russia, Japan, because of that cold tolerance. We also have big outbreaks that have been linked back to refrigerated blood and blood products that will grow out these pathogenic Yersinia species. It's a close-up of what a colony looks like. You can see there's a little bit of pink pigment that's produced in the center. Uncommon in the US. I guess we probably do not see a lot of species, but there are a lot of cases, but we do see them in colder climates generally. In terms of the pathology, they too, this is the third organism in a row that we've talked about that has that same launch point. When you get down into the intestines, they're targeting the M cells predominantly and invading in that manner. And then from there, it's a little bit like Salmonella. They will cause, they will oftentimes breach that layer through the M cells and get down into the mesenteric lymph nodes. The damage can be extensive. You can have some necrosis in the intestinal lining as well. with a pseudoappendicitis, when that presents, I need to double check whether it's right upper quadrant or right lower quadrant. I'm not sure. So I'll get back to you on that. I'm just questioning that in my mind. Other complications are polyarthritis. Again, like just sequelae that affect the joints. A unique sequela associated with these enteric Yersinia species is what's shown on this picture on the right here, erythema nodosum. And this is when you have involvement of the skin, so the bacteria will get out and you'll have some sort of inflammatory reaction in the skin. You get nodules, like red erythematous nodules under the skin. Usually that's in the lower extremities, like the legs on this picture here. The shedding period is extensive, up to 3 months of shedding. And as is the case with Yersinia pestis as well, you have these YOPs, these Yersinia outer proteins, as a major virulence factor. And those are responsible for a number of consequences for these cells. Yes, sir? Right lower? Okay, cool. Thank you for bringing that. Okay, so on your slides, if you would, RLQ, right lower quadrant tenderness for pseudoappendicitis. And yeah, just a little correction there. Right. Lower quadrant. Okay. Thank you. Okay. Klebsiella, still in this family of Enterobacteriaceae, talking about Klebsiella. This is another major enteric pathogen. 2 species we talk about a lot are Klebsiella pneumoniae, that colonizes the GI tract, but also colonizes the nasopharynx as well, and Oxytoca, Klebsiella oxytoca. That is far more predominant in the GI tract. With both of these species, and with the whole genus, they're associated with heavy capsule production. Hypermucoid colonies that look like these. If you culture a stool specimen on selective media or subculture it, these colonies are very classic for Klebsiella. They just look very slimy because of that extensive capsule that's produced. That capsule has 80 plus K antigens. That's not 80,000. It's like about 80 K capsule antigens on it, which is a lot, and it has made it very difficult to come up with vaccines for this. It is a serious enough pathogen where they have tried to develop vaccines against Klebsiella. It's an escape pathogen too. Remember the K and escape? It's Klebsiella. So you know antibiotic resistance is going to be a thing for these guys. And indeed, they do produce ESBLs. These are extended spectrum beta-lactamases that will knock out several classes of beta-lactams. So your penicillins, your cephalosporins, at least first and second generation cephalosporins. And also with the KPC strains, that stands for Klebsiella pneumoniae carbapenemase producing, that will also knock out carbapenems, as the name suggests. So we monitor and do a lot of surveillance for KPC strains. If you look at the list of HAIs, these nosocomial infections associated with Klebsiella, this list you're going to see a lot in subsequent slides. We talk about the remaining organisms. You can see UTIs, pneumonia, bloodstream infection, BSIs, bacteremia, wound surgical site infections, endocarditis, and meningitis. This is a common list. So when you have these common opportunistic infections in hospital-associated environments like this, it's very important to have that lab result where the lab tells you what is growing up, and then does an AST as well, because antibiotic resistance is such an issue with these guys, these enteric bacteria. Yeah?
On some of the slides you said they're not nosocomial. Are those interchangeable terms?
I use
Hospital-associated versus nosocomial?
Yeah. So yeah, when I say nosocomial or hospital acquired, I'm usually talking about people who are going into the hospital, and because of the concentration of pathogens among sick people at the hospital, they will pick up and acquire new infections at the hospital. So Klebsiella pneumoniae is one that the patient goes in for treatment for something, and they can pick up nosocomial hospital-acquired infections, if that makes sense. So remember when we were, appreciate your honesty. remember we were talking about like a slide or two ago, Yersinia intercolitica instead of tuberculosis, and some of the common transmission methods with those were through food-producing animals, consumption of undercooked pork and unpasteurized milk, contaminated water, right? So that's not nosocomially acquired. That's because you're eating stuff that is contaminated in the food chain. That's how you're acquiring it. But that's not the same with Klebsiella. Klebsiella, you don't get Klebsiella usually, like this slew of opportunistic infections, by eating, cold cuts and whatever, drinking unpasteurized milk. You usually get it because you've gone into the hospital, you're already sick, you might be on antibiotics or something else, and you pick it up as an opportunistic pathogen. So like all these are classic hospital-acquired infections that you get. UTIs. It's going to become like annoying and obnoxious. Well, it probably already is too, but you'll see this repetitively on these slides with enteric bacteria that cause these nosocomial infections. Skipping ahead, Enterobacter, HAIs, pneumonia, UTIs, wound infections, device-associated infections, Proteus. You pick up this a lot in hospitals as well. Providencia, big hospital-associated infection. Very much an opportunistic pathogen. So, yeah, transmission sources very important. That's something to note when you're studying for this stuff. With the pneumonia here, Klebsiella pneumoniae is the one that is, not surprisingly, mostly indicated with pneumonia infections. And that can cause some really serious pneumonia. It's worth actually pointing out, even though a lot of these other bugs can cause pneumonia as well, the pathology that's caused by a Klebsiella infection in the lungs is really severe. That too has a description that is really colorful. They call that current jelly sputum. We were talking about current jelly stool before with another organism, but this causes bloody sputum. So very severe pneumonia, you have necrosis in the lungs. So yeah, and that's characteristic and distinctive of Klebsiella pneumoniae. Enterobacter, as a genus, nothing too remarkable. It is a normal colonizer of the large intestine, of the colon. There are a bunch of species beyond these two that I mentioned here, Aragonese and Polypi, but these two are the most clinically relevant ones. And treatment does differ between them, so it's usually good to identify and differentiate them through lab diagnostics as well. I'm just going to make a point about that. I forgot what that was. Okay, we'll come back to me. But again, with these infections that this particular bacteria is capable of causing, it's just these are opportunistic infections, so we won't go over them in too much detail on these slides. In the escape pathogens, there are 2 E's, sometimes 3 if you count E. coli. One of the hard, fast, permanent members is the Enterobacter genus. So this too, antibiotic resistance you see a lot of. In particular, the expression of this AMP-C gene, these strains that you pick up in hospitals that have high carriage rate of AMP-C genes, that encodes for a chromosomal beta-lactamase. And that confers resistance to beta-lactams. They will also have intrinsic resistance to ampicillin, first and second generation cellulose ones. I think some third generation as well. Proteus is an interesting one, not because of the opportunistic infections per se, but because of its characteristics when you grow it up on a plate. So this is, some of these species are capable of causing diarrhea or UTIs or wound infections, but Mirabilis is the one that is mostly associated with UTIs in this genus, Proteus mirabilis. And when you grow that up from a urine specimen or any member of this genus, it has this very distinctive morphology, colony morphology, called swarming morphology. And that's because these bacteria, they produce capsule and they also have sort of like a gliding motility on that auger. So they grow and they just slide and ripple across the plate like that. This is a mediate called a Heck plate, which has a pH indicator, bromophenol fluid pH indicator. So it looks like it's starting to ferment some of the carbohydrates in that mediate type as well, but nothing else quite looks like Proteus on a plate. And that's because it has, on an individual cell level, it has so many flagella. It has hundreds of flagella. You see the cartoon there, Proteus mirabilis has all those flagella, but also here, hundreds, if not thousands, of flagella. And that's important for it to be able to maneuver in environments like in the bladder if it's causing serious UTIs, and also in the gut. Also, it produces a virulence factor that we haven't talked about much yet, and that is a urease. So bacteria that produce urease are able to cleave urea into ammonia. And there's a quick lab identification test we could do, a biochemical test, to see if it's urease positive. If it is, it could be further evidence you're dealing with a Proteus species. Providencia, there's not a whole lot to say about this bacteria. Common nosocomial pathogen, causes kind of the same infections that you would expect from opportunistic conditions in a hospital. Severe burns is something that to take note of. Patients have severe burns. Providencia is one of several bacteria that you could suspect. That's because that patient's primary barrier is destroyed, so you get all sorts of opportunistic infections, and also these long-term indwelling catheters as well. Okay, so I had this slide in as a break with this friendly little kitten after all this talk about diarrhea, but then I decided to add a couple interesting snippets from the AFHSD, the Armed Forces Health Surveillance Division, who posts like daily updates on what's circulating in the different GCCs across the globe. Super interesting. So I just pulled a couple that are relevant to today's lecture about enteric bacteria. These are things that have been circulating just this past week. So these are extremely timely outbreaks across the world. In Africa, we have a cholera outbreak. This was, I think on Tuesday I saw this one, over 1,500 people got cholera. We're going to talk about cholera soon. I'll get to that one in a minute. Here in the US, on the southern border here in Texas, there is a cucumber recall. We don't know what the bacteria is that is contaminating these cucumbers, but I can't wait to find out. I'll be following up on that one. Fuentes Farms in McAllen, whoever McAllen is. No cases reported yet, so they probably just identified it in routine surveillance. Over in CENTCOM, we've got some things happening in Pakistan and Yemen. 68% of illnesses in the country of Pakistan are waterborne, and that is because they have no effective sewage treatment. So that doesn't seem like an event so much as just a big problem, long-term systemic issue in Pakistan, that they have the inability to prevent waterborne diseases right now because they don't have the treatment facilities. Yemen also dealing with a bunch of cholera cases, 18,000 cholera cases in Yemen right now, 10 deaths so far. Here we are halfway through 2025. USACOM over in Europe, Portugal and France, we've got some stuff going on. Again, like Portugal, we don't know what this organism is, but waterborne in Portugal, 5 deaths per 100,000 in 2023. And then in France, there is currently an E. coli outbreak, 18 cases and 1 death up in northern France. So just a little snippet of stuff that's circulating across the globe right now. All right, so the reason why that, are you guys doing okay? Do you need a quick break before we start on non-interruptory C? Okay, so the reason why that little filler slide was in there with the kitten was also to signify that we were finally moving away from the Enterobacteriaceae family, and the remaining genera that we're talking about today, hopefully Aeromonas and Vibrio and Campylobacter and Helicobacter, these 4 genera, are not associated with carriage as much in its GI tract. A lot of these genera are associated more with bacteria that are in aquatic systems. So with Aeromonas, for example, starting off with this one, its natural habitat is going to be mostly in freshwater environments. These days, most cases of Aeromonas are caused by drinking contaminated water. So you can get some gastroenteritis associated with that. Historically, though, there have been some really funky transmission routes. One involving medicinal leeches, which used to be used as treatment for wounds to help aid in healing. They put medicinal leeches, like I can't remember the scientific name of these leeches that were used, but they'd put them on patients, and the enzymes in those leeches' saliva would help facilitate more rapid healing. So there have been cases, even in recent medical use, where they've used medicinal leeches. There was a 68-year-old woman who had basal cell epitheliomas on her face and up on her forehead. So they did some leech treatments with her, and she got a really, really nasty skin infection where they'd applied those leeches. So they did some, they cultured the leeches themselves, they cultured the skin that was infected from the patient, and they cultured the tank water from where the leeches were taken. And all of them grew out Aeromonas hydrophila, this pathogenic species of Aeromonas. So stopped the leech treatments, and she healed without further incident. But that's one of the reasons why, if you're using medicinal leeches, you have to really carefully screen them and make sure they're not carrying Aeromonas. It's just in the water, and it tends to get in a lot of the aquafauna as well. So again, if you have ingestion through contaminated water, gastroenteritis typically, but also something we'll see with some of these other organisms as well. If you have an open wound and you're going into freshwater environments, wading into that water that has Aeromonas in it, those Aeromonas can infect those wounds and cause some pretty nasty, like localized wound infections. So the recommendation is usually do not go into water with open wounds, freshwater or salt water. See that in secondary fibrils. Some opportunistic infections are possible as well, systemic infections, and kind of the usual high-risk groups are particularly susceptible to Aeromonas infections. All right, Vibrios. This is a major genus of importance, a lot of important members. This is the genus that has cholera, Vibrio cholerae organism. For these guys, their natural habitat is also water. They thrive typically in warmer water, and they're halophilic, which means they prefer slightly saltier conditions. For that reason, they can do well out in ocean water. So, like the Gulf of Mexico, for example, is fine for Vibrio to grow, especially in those warmer months. We've got a bunch of different species of Vibrios, but the ones that are important are these four. Cholera is by far the most important one. Parahemolyticus, Mollificus, and Algenolyticus. There's an electron micrograph in the upper left-hand part of your screen. You can see the shape of them is a little bit different. They're not like a perfect rod. They're slightly curved. And they're also flagellated, which is important for them to swim around and get some motility. In terms of their serogroups, they have a bunch of different O antigens, and that's super important, over 200 different serogroups of Vibrio cholera alone. Talk about that a little bit more. Of those 200 plus serogroups, there are two that are really important, O1 and O139. Those are the serogroups that are associated with high carriage of cholera toxin, which is a major virulence factor when we're talking about Vibrio cholera. Further divided, if you look at O1, which is one of those serogroups, again, that has some different biotypes, which means it has different associations with geography. We have a classical biotype and an L-Tor biotype. Throughout history, we kind of have been dealing with different pandemics of cholera. Right now, we're in the 7th major pandemic of cholera, so it's kind of like a slow burn one. It's been going on for 30 years, and that's the epicenter of that outbreak has been kind of up here in the Ganges Delta region between Bangladesh and India. So up here you have some people bathing in the Ganges River in that delta, and that water is kind of notoriously polluted. It's where animals are washed and animals drink and animals defecate, and people do their laundry there and they get the drinking water. So cholera, that's kind of like the epicenter for cholera globally, is right in that region. And that is where you find some of these more virulent strains as well. So classical has been circulating globally for a while. L. tor is less virulent, but it's more common. And L. tor has been linked to the few cases that we've seen here in the U.S. We really do not see cholera cases in the U.S., except if there are things like emergencies and natural disasters like Hurricane Katrina, Hurricane Rita back in 2004, 2005, right? Then we actually saw homegrown cases of Vibrio of cholera in the United States. But that was because we had massive flooding and contamination of water, so people were getting sick here. In our hemisphere, in the Western Hemisphere, some of the hot spots are over in Haiti. Haiti is oftentimes dealing with cholera outbreaks because, again, they cannot keep their water supply clean. So that's always a problem. In terms of transmission, there's a couple ways you can get cholera. It's usually primarily from ingesting contaminated water. It's primary transmission. You can also get it from eating, kind of famously, shellfish, because these are filtered organisms, the oysters, mussels, clams, etc. They do this with a lot of different bacteria, not just Vibrio cholera, but because of the way they filter out water when they're just feeding, they concentrate those bacteria. So when you eat raw oysters, whatever, you're getting a pretty heavy inoculum of bacteria if they're in polluted waters in the first place. So where those oysters and clams are harvested is important as well. It is also possible to spread person to person if you have cholera. But that's usually after those strains have had a chance to passage through the human body and get adapted to the human. Because remember, these are environmental bacteria. They're good at warm, salty water, and if they passage through human, they need to adapt to the human body. By the time they're released from an infected person and potentially transmitted to another person, they have those adaptation features. Because of that, their infectivity goes up 2 or 3-fold greater. So they're much more effective at that point, and you can get person-to-person transmission. Also note, they're not particularly acid stable, so that's part of the reason why such a huge inoculum is required for the unadapted strains, environmental strains. Most of them are destroyed by the stomach acid as they're transiting down your GI tract. So you do have to consume a large number. Some exceptions would be people who have achlorhydria, or achlorhydria, and that's a condition where your stomach isn't acidified as much. You might be on some sort of, some sort of medical treatment, some treatment where your pH is higher than it normally is. And because of that, more bacteria survive, and it takes fewer bacteria to cause infection, like many, many times fewer bacteria. Once those strains are shed, they usually will lose some of that hyperinfectivity that they pick up through transmission through people, though. In terms of virulence factors, just attachment is one, a non-invasive attachment virulence factor. They have pili. That cartoon is showing the primary way that Vibrio cholerae bacteria will pick up cholera toxin genes, and that is through transduction, which we've talked about in the past. Bacteriophages will carry that gene and transmit those genes to susceptible cholera organisms. That cholera toxin acts very much the same way that ETEC does. So the symptoms and the presentation of cholera are similar to the presentation of ETEC. Watery diarrhea, probably worse because you have additional toxins with Vibrio cholera as well. So not just the cholera toxin, but you have zona occludens toxin, which will loosen up tight junctions in between epithelial cells. You've got those accessory cholera enterotoxins, which will also contribute to that pathology. So if you have an infection with all of those virulence factors and all those toxins, you can get some incredibly severe diarrhea. Patients who have severe cholera can lose up to 20 liters of fluid a day, or a liter an hour. If you count, if you know how much fluid is in the body to begin with, you know that you'd have to be on some extremely aggressive rehydration regimen in order to keep pace with that. But that's how people generally die when they have severe cholera infections. They are dehydrated because they can't keep up with fluid replacement. They are losing it at a very rapid rate. These symptoms that are associated with severe disease, the cramping, the restlessness, particularly with children that have cholera, are all related to that severe dehydration. The famous description for cholera stools is rice water stools. Initially, when the patient first gets sick, it's especially ricey, like translucent looking. It has a lot of protein and material in there still. But with each hour that they're losing fluids, it becomes clearer and clearer and clearer because the patients are just getting flushed out. They have almost nothing but water going through them at that point, so it becomes very clear. Some of these complications with dehydration, they could potentially lead to fatal outcomes, would be total kidney failure, metabolic acidosis, where your blood is no longer able to be buffered, pH is no longer buffered. Hyperkalemia, where you have potassium levels in the blood that start dropping. That causes electrolyte imbalances, which can cause neurological complications, which can lead to coma and death. Here we see a couple images. I believe these are out of Bangladesh. This is in Dhaka. On the left, we have a cholera ward. So this is probably like an outbreak situation where a bunch of people have been infected, and they set up a cholera ward. Rows of patients, lots of children, classic cholera cots set up, cholera cots that have circle cut out in them so patients don't need to get up because they're just continually releasing rice water stools into that bucket that's collected there. They've got an IV line set up, just kind of makeshift, hanging off the ceiling there, just trying to keep pace and keep the patients hydrated. And this is a child that is being administered with ORS, oral hydration, rehydration solutions, which has a bunch of electrolytes and water. But you can see like the gauntness in this kid, sunken eyes, sunken face, really serious dehydration. In terms of diagnosis, some of it is hard to grow per se, but we do not get a lot of cases in the US again. We do have specialized media, TCBS, biocitrate, bile salt, and sucrose media, which has a dye in it. It's a green otter type. So when you have Vibrio cholera and it ferments the sucrose, you'll get a yellow fermentation that's visible, and that'll distinguish it from other pathogenic types of Vibrio, like Parahemolyticus, which will not ferment that same sugar source. In terms of treatment, antibiotics wouldn't necessarily be contraindicated, but because the main risk is dehydration, the emphasis and the priority goes to making sure that patient is rehydrated. So hydration therapy is most important. Antibiotics are very much secondary to that strategy. We do have resistance to some antibiotics. And with some of those hot spots, it's just next to impossible. You can tell people all day long how to avoid Vibrio cholera, but even people who are sick, if they don't have access to clean water, they're going to continue the exposure route over and over again. So it's a very frustrating, difficult to treat disease in those situations. There is a vaccine available. I don't know much about it. We don't have it available here in the US, but they do have it in some of those endemic areas, like in Haiti, for example. Other Vibrio species, these two common to Vibrio cholera, dry and coastal waters. There's a seasonality where we see a spike in Vibrio cases, and that's in the warmer months. Due to global warming and climate change, we have cases that keep kind of creeping up in the United States with these other Vibrio diseases along the eastern seaboard. And it's almost always eastern seaboard. We don't see a lot of cases out on the west coast, but every year it's like we get cases up now to Virginia and up to mid-Atlantic, even in New England states, because the warming of those waters is more conducive to the growth of Vibrio cholera, or the Vibrio species on this list. 80,000 Verbiosis cases a year in the United States. That includes all of these and some other species that aren't as predominant as these. Usually the routes of infection for all of these is pretty much the same. You either get it through drinking contaminated water or ingesting those shellfish, you've got that concentrated levels of bacteria, or by wading out, classically, wading out into waters with a wound that's exposed. And those bacteria are able to get in, and they have enough virulence factors to do some damage. The first one, Vibrio parahemolyticus, is not typically associated with super severe infection, but it is the most common of those Vibrios in the United States. So the majority of those cases are going to be caused by Vibrio parahemolyticus. It's usually associated with gastroenteritis. That gastroenteritis is oftentimes mild, can be more severe, but it's usually pretty mild, usually self-limiting, up to 7 days. And this too, you can get some wound infections, but they're not nearly as severe as the ones that are caused by Vibrio vulnificus. So usually more like cellulitis and things like that when you are exposed to contaminated water. Vibrio vulnificus is the big scary one. You might have heard about this one before. It's enough of a problem where this too has caused the CDC to issue some public health warnings about the dangers of wading into coastal regions in the United States, like the Gulf Coast states, for example, Texas, Louisiana, Mississippi, Alabama, maybe Florida. I was just vacationed there over December, went across the Cajun Riviera and walked across these beautiful beaches in Alabama. Totally, like no one was there. It was great. But the entire time I'm also thinking like, oh, Vibrio vulnificus. But it's December. It's not the high season. So, but yeah, that's like the classic case. Particularly if the patient is older, like, usually it's like the classic case is male, 50s, 60s, 70s, a little bit older, and with comorbidities, diabetic, something like that, something predisposing where they might not have as easy of a time clearing this. But how severe this infection gets when you get Vibrio vulnificus relates also not just to the patient's immune status, but also to the inoculum, the amount of bacteria that get into the wound, the size of the wound in the first place, and stuff like that. So there are a lot of things. But at its very worst, this is one of those terrifying flesh-eating diseases that you read about that are associated with necrotizing fasciitis and total destruction of tissue, progressive debridement, amputation, all of that. Sorry, Dakota, you had a question.
Yes, ma'am. Is there any proactivity with a lot of these super pathogens we find in the water? Like, how are we just waiting for patients to get these and then treating, or is there a way to lessen the bacteria in these bodies?
That's a good question. So there have been, like in terms of prevention, a couple things. There's education, like the CDC public health thing, telling people that there is a risk, telling them about the months of the year to avoid the waters, warning them about eating raw shellfish. So that falls into the category of PrevMed stuff. For doctors, recognizing, especially if you're in a Gulf Coast state or on the Eastern Seaboard, being able to recognize signs and symptoms, patient history, knowing what questions to ask your patient if you suspect that they might have one of these Vibrios. And that's sort of the strategy, but beyond that, I don't know of any other.
So there's no, like, I guess, you're not diluting antibiotics into a body of water to kill or prevent it.
No, you're not. But they have also, like, there have been some blooms almost, you're aware of like red algal blooms, right, associated with pollution. When you have those red algal blooms, you also have imbalances in the ecosystem at large, and that has been associated with increased levels of some of these pathogenic Vibrio species. So if we were able to do a better job at cleaning up our waters, that would probably help as well. And you, kind of hit upon a point, last remaining point to make on this slide with the diagnosis here. Empiric diagnosis, very important. Just initial things in your differential when you see patients who are in extraordinary pain, it's going to hurt pretty bad. Discolored tissue like this, very discolored. Bully, talked about bully before. What are bully? Blisters like this, that's classic for Vibrio vulnificus. So it's empiric, it could be other things, even in the United States, right? It could be other flesh-eating types of bacteria, but this would at least add Vibrio vulnificus to your differential, especially if your patient is in a place like Galveston, Corpus Christi, another place in the Gulf Coast, and they've been wading into waters, they have an open wound. A lot of times these have points of origin on the lower limbs where people have been wading into those waters. So that, you can also get Vibrio vulnificus infections just through ingestion, same way, but it tends to be kind of the inverse of parahemolyticus. So less severe gastroenteritis, less common. but really much more severe wound infections. So with Vulnificus. Last one to talk about is Vibrio alginolyticus, also common in marine environments, widespread distribution. Do see it in the United States as well. Has an interesting association with pufferfish. If you've ever heard about the use of pufferfish in culinary applications and the dangers of tetrodotoxin ingestion, chefs, particularly sushi chefs who are working with pufferfish, have to be very careful about which organs they are working around when they're preparing these fish, because this bacteria can kind of concentrate in some of those organs, particularly the liver. So you have to know what you're doing when you're preparing these fish. Otherwise, people can ingest the tetrodotoxin, which is a neurotoxin produced by some of these bacterial species. This isn't the only one. There are others that can produce tetrodotoxin as well, but that can cause some neurological problems, tetrodotoxin exposure. Also, just from seaweed exposure or seawater exposure, you can get cases of otitis externa, also known as swimmer's ear, an external ear infection where the ear canal gets infected. You get some eye infections with that as well. There was an interesting case report of a woman who put a seaweed wrap. It was like some homeopathic remedy. She had a wound, she wrapped seaweed around it, and lo and behold, she got a really nasty skin infection. It wasn't like a flesh-eating thing, but nasty wound infection because she wrapped seaweed that had Vibrio alginolyticus on it. All right. Campylobacter. Start on this one. I don't think we'll finish this deck today, unfortunately. We'll get most of the way through it. Campylobacter is probably the most important genera for you, or genus for you guys to be aware of the 4 non-Enterobacteriaceae. So this, starting off with a table, which might not have been the best idea. I have the 4 major species of Campylobacter that are pathogenic potential, but by far and away the most important one for you guys to know is jejuni, Campylobacter jejuni. Also important is Campylobacter coli. These two, between the two of them, cause a lot of gastroenteritis cases. We'll talk about that more in the next slide. Upsaliensis is another species that is implicated in cases of gastroenteritis as well. It's not as common. Another thing to be aware of is Guillain-Barré syndrome and its association with Campylobacter jejuni. We've talked about Guillain-Barré syndrome before. You guys remember anything about the context of that discussion? Not at all. Cool.
Rips them and takes up the myelin sheath.
Exactly. Yes, it's associated with it's one of those inappropriate immune responses where you've unfortunately raised antibodies that were directed against the bacteria. In this case, against Campylobacter. And unfortunately, those antibodies are cross-reactive and they start attacking the myelin sheath on nerve cells, which can progress potentially to Guillain-Barré, which is a syndrome that's associated with loss of sensation, loss of nerve function, tingling sensation, sometimes partial paralysis. Very debilitating, bad sequela to get Guillain-Barré. So you need to be able to associate the Guillain-Barré with Campylobacter jejuni and Upsaliensis, but mostly Campylobacter jejuni. That's an important one for you guys to know, like throughout ITAP, throughout your careers. Also, common reservoir hosts for these, not a strict human pathogen, not really nosocomial, but associated with the food supply. These bacteria are in the intestines of those food-producing animals, so you oftentimes get them when you are eating undercooked whatever. With jejuni, poultry, it's bolded for a reason because it's really linked to undercooked chicken, but cattle and sheep as well. So here we go. Number 1 cause of gastroenteritis in the world. Definitely need to know that. It's a huge statement. Lots of things can cause gastroenteritis, and this is number 1. Number 1 cause of bacterial diarrhea in the United States. It's another big statement to make. In terms of how this thing looks, we talked about like Vibrio having that kind of curved morphology and some flagella coming off of it. The morphology of Campylobacter is a little bit different. It's even curvier, and that aids in its motility. It needs to be able to swim through viscous environments too. You can't really see this morphology on a gram stain. This is some micrograph, artificially colored micrograph, but you can see that it has this twisty morphology. I don't know if I put a picture in. Yeah, I put a picture in that shows the gram stain, but it's really hard to see. Sometimes people describe them as gull wing shaped or S-shaped, cone shaped, stuff like that. They have that unique morphology there. In terms of presentation, when you think about etiologies of bloody diarrhea and dysentery, this is up there. It's up there with Shigella, and it's up there with STEC. So it doesn't necessarily keep in mind that this is a relatively small number of cases, but it is entirely capable of causing dysentery. It has virulence factors, at least some strains do. Really severe abdominal pain, nausea, vomiting, can become very serious and become septicemic. Usually these two will resolve in less than a week on their own without any antibiotics. Transmission, as we alluded to on the last slide, is when you have fecal material from those animals somehow getting into the food supply. I think I've hit that point about chicken enough, but when you think about raw chicken, what are two organisms that we've talked about today that should pop into your mind for patients who are sick? Salmonella and Campylobacter jejuni, especially Campylobacter jejuni. For diagnosis, we have a specialized media type called Campy blood auger. This is part of a routine stool culture workup. It's so common, it's definitely in that routine workup. So every lab should be able to identify Campylobacter with not too much of an issue. That said, it does have some specialized growth conditions. Since jejuni is so well adapted to birds, and birds have higher body temperature, 42 degrees, labs will keep incubators set at 42 degrees to facilitate faster growth of Campylobacter jejuni. It's also microaerophilic, so instead of the normal atmospheric 20% oxygen, we keep their incubators at 5 to 10% oxygen with elevated CO2, around like, I don't know, like 10% CO2. I think normal atmospheric levels are less than 1%. So capnophilic means it likes CO2 and it doesn't like air. And it's also slow growing, so a lot of these bacteria that we've been talking about, culture them, or streak them out on a plate, come back the next morning and you'll have something to work with. These guys, it'll probably be an extra day minimum, possibly 48 to 72 hours to culture them. They just don't grow that fast. For treatment, if you can get it again, it's much like when we're talking about Salmonella, there is a severity index that you guys will, as part of your education, learn about. But if the patient isn't presenting in a severe way, you might be able to just get away with no antibiotics and letting these infections resolve on their own. Oh, darn. Keep going. Okay. All right. You guys have AMP after this, right? Okay. I'll just lecture till Mr. Ruggiero comes, right? Okay. All right. Cool. Yeah. No, that'd be great if we got through this. But this is a big organism. Whatever. We'll see how far we get. Helicobacter, H. pylori. Really important one. A lot of us are colonized with it. It too has kind of a funky morphology, the trend we're picking up on. But I led off with talking about Aeromonas and Vibrio, and well, those in particular being associated with water. This is not one of those organisms. It's more like Campylobacter, in that it likes to be in the GI tract, but it's not an animal. Doesn't have animal reservoirs. This is a strict human pathogen. So it's maintained in the human population because it can be relatively mild and, in most cases, asymptomatic. That's back to that theme of if you play nice, you can live in this long-term association with this host. So this one is adapted, knows how to play nice. It also knows how to be super mean. Talk about some of its virulence factors. But you get it through two ways. Primarily, fecal oral route. Low sanitation conditions, it's associated with like unclean environments, basically, low hygiene levels. You can also get it through oral transmission, through saliva, definitely easily through kissing. It's shed in saliva, so definitely kissing. But also, like, you utensils is a common way of transmitting it. Sharing utensils, sharing glasses that have somebody else's saliva on it, things like that. And that's because this bacteria colonizes the stomach, and unfortunately, with a lot of people, especially if they have GERD, which we'll talk about in a second, that bacteria gets transmitted and mixed up into the saliva, so you can get it that way as well. Generally, when somebody in a household is colonized with H. pylori, the entire household is going to be colonized with H. pylori, just because of the close living conditions. 60% of the world infected, higher in developing countries because of that sanitation issue. This gram stain from a pure culture, you can kind of see that morphology a little bit, but it's hard to make out how spirally it is. Okay, as I mentioned, majority of these infections asymptomatic, and that tracks with its ability to stay in the human population long term. The diseases or the problems that are associated with are peptic ulcers. We used to blame ulcers on stress, and then very famously we identified that there was actually an infectious bacterial etiology that's primarily responsible for stomach gastric ulcers. This organism, it will, among other things, it'll degrade the tissue in like the lining of the stomach, and if that tissue gets eroded sufficiently, you can get those ulcers starting to form in the stomach. So that's usually how that happens. But they are capable of colonizing this organ, which has incredibly low pH, because they are acid tolerant, and also because they produce urease, which we talked about previously. And we know that urease is an enzyme that will cleave urea and cause the pH to go up, to elevate. So that nice low acidic pH in the stomach that's supposed to protect you against pathogens is no longer there. It's been neutralized a little bit by virtue of the fact that they have urease protection. And that's also a test we use in the lab to see if we have a urease producing organism. So you have these things colonizing, they tip over from a commensal state to causing an actual disease, it's pathogenesis, and as a result, you get some of these symptoms. Epigastric pain, which is usually described as like a gnawing sensation in the stomach. Decreased appetite, early satiety, I can never pronounce this word, but satiety, thank you, satiety, just feeling full, nausea, belching, I'm not really sure about the pathology, or the pathology there. But the halitosis, I think, is the result of some of the just the metabolism that's going on. You get incredibly bad breath associated with H. pylori infections, some gum bleeding, and heartburn. GERD, which I mentioned on the last slide, is when the sphincter that's at the bottom of the esophagus serves to close off the esophagus from stomach acid splashing up. It's when there's a problem with that sphincter's ability to close. So you get frequent splashing of stomach acid up into the esophagus, and that can contribute to those bacteria getting up into the esophagus as well. It's more of a transmission thing. With these risks of esophageal and stomach cancers, that's related to the damage that's done to those tissues constantly over years of being colonized with these organisms. So there's like a wound repair cycle that occurs, and that is associated with these cancerous conditions. Gastric adenocarcinoma is the most common one. There's also a lymphoma associated with the lymphoid tissue, the gastric lymphoid tissue, non-Hodgkin's lymphoma. Are you okay if I go like a couple minutes late?
I'm great.
Cool. Okay. Thanks. I have like two more slide or two left. In terms of treatments, just to touch upon this, if the patients are symptomatic and this is causing a lot of problems, there are a couple different antibiotics that are thrown at these organisms in combination. So clarithromycin is one of them. There's oftentimes some others as well. And then they'll oftentimes prescribe like a proton pump inhibitor to help restore the normal pH back to the stomach. That's just to alleviate the symptoms. In terms of laboratory diagnosis, we would not choose to culture most of the time. For one thing, these bacteria are highly adherent to the mucosa, so it's hard to actually get them reliably. in those samples. If you wanted to get them, you could do a gastric biopsy, which is an invasive procedure. We have some non-invasive options, so this is not the preferred method at all, if we can help it. Some more common methods are fecal antigen assay, where we basically just use a stool specimen and probe it with anti-sera against Helicobacter pylori, see if it has those antigens present in the stool specimen. The rapid urease test tests to see whether or not you have urease production. The urea breath test is similar to this, but in this method, you're actually asking the patient to swallow a liquid that is radiolabeled, and that liquid has, so normally you have carbon 12, right? But this radiolabeled liquid will have carbon 13 or carbon 14. So they swallow that, and when that liquid reaches the stomach, if there's H. pylori in it, they will cleave the urea, and that urea will be radiolabeled. And the ammonia that is released into the breath will be also radiolabeled. So there's like a balloon that you have that patient breathe into, and if you have H. pylori infection, you will have this radiolabeled carbon dioxide you can collect in that balloon, take over to a scintillation counter, and have that measured, the radioactivity in that specimen measured. So that's a non-invasive way. It's very sensitive, very specific, and it's still done with diagnosing H. pylori infections. You can also do histology. That's what we're seeing up here in the top. This is a biopsy of tissue, 10x objective, 40x, 100x. You can see the staining of those Helicobacter pylori organisms. We use an antibody to stain it, so you can see that in the tissue. This is invasive, which sucks, but the nice thing is you can also see if there's pathology, if there's damage to that tissue. So you can see ulcerated stomach tissue, which is of value, so possibly worth it. And then lastly, serology. If the patient has a serious infection, they should have antibodies to it. The only problem is you won't be able to tell if it's like a current infection or a past infection. You just see if they have IgG. So that might be useful as more of an adjunct to confirm if you suspect they have H. pylori. All right. Sorry for going over any questions. I didn't go over. It's my 55. Any questions about this, especially like the last 4 genera that we covered today? That was a bit fast, but okay. We'll get off and go away. We'll see you guys tomorrow. Thank you guys.